Hello everyone, this is your chapter 1 to 3 review. I'm not going to do all of the questions, of course, but I will do a small sample. In this example, I graphed it on Desmos, and I found that the x-intercepts were -1, 1, and 2. Technically, we didn't learn how to divide and stuff and find those factors until chapter 2. So at this point, you can just use Desmos to get your x and y intercepts. Okay, for number 2, it says describe the symmetry and the end behavior of each function. I've done number 2a. It's 5x to the 4 minus 2x to the 3 plus x squared minus 3x plus 1. This here shows that it's an even degree coefficient, so that means that our end behavior is from quadrant 2 to quadrant 1. And because it has these terms in here that have degree 1, it's not going to be symmetrical. Number 3 says, determine the average rate of change of the cubic function f at x equals -4x to the 3 for the interval x equals 2.0 to x equals 2.5. I'm first going to find the function at 2.0 and the function at 2.5. The function at 2 is -32, and the value of function at 2.5 is -62.5. To find our average rate of change, I'm going to use our slope formula. So I'll take the second y value, subtract the first y value, and over top, or on the bottom, I'll second x value, subtract our first x value. So I'm going to do that now. So putting our x values and y values in, doing my calculations, I get an average rate of change in that interval of -61. For number 5, I have a function represented by this table of values. And it says to sketch a graph of the function, assuming that all zeros are given in the table and that they are each of order 2. I'm going to determine the degree of the function, although it shows that there are 2 zeros, one here and one here, and each of those of order 2. So it looks like it's going to be degree 4. But using our first differences, and then our second differences, and third differences, we can see that the fourth differences are equivalent. So that means that it is definitely degree 4. We also know from our formula that the lead coefficient a times n factorial equals -48, and n is the degree. So now we can find the lead coefficient. So the degree is 4, so n is 4. I put it in here and I get 4 factorial. 4 factorial is 4 times 3 times 2 times 1, which gives me 24, times the a, equals -48. And then a, then, the leading coefficient, is -2. So then our final equation is given by y equals -2, there's our lead coefficient, our 2 zeros, so the first one was 1, giving me x minus 1 squared because it's order of 2, and the second 0 is -3, so that gives us x plus 3, also order 2. And then part D says what's the effect of the leading coefficient. Because this is negative and this is an even degree polynomial, then it will be going from quadrant 3 to quadrant 4. Okay, so I've already done the work on this one. So this is our function, and we've been asked to find the instantaneous rate of change at x equals 2. So we basically want to use our rate of change formula over and over again and get closer to 2. So first I'm going to try f at 3 and f at 2, figure out what those are. I'll use the slope formula. So there's my f at 3, my f at 2, and the 3 and the 2, and it gives me a slope of -2. Now I'm going to find f at 2.5, and you can see I'm over here. I've done all of these on Desmos. If you put your f function in first, then you can just change your x to the different numbers that you want. It's a really quick way to calculate. So f at 2.5 over here was -10.65. This is f at 2, because that's what we want to get close to. Do the subtraction. On the bottom we end up with a 0.5, so we end up with -3.25 as our rate of change between 2 and 2.5. Now let's try our rate of change between 2.1 and 2. Again, I look over here, my 2.1 was -9.389. Do the calculations and I end up with -3.89. Now I'm going to get closer again, 2.01, and change that with 2, and I end up with -3.98. Then I get even closer to 2 at 2.001, and I subtract the f at 2, and I get -3.99. So we're getting closer and closer to -4. So I would say the instantaneous rate of change is -4. For the roller coaster question, we can see all of our x-intercepts in here, 0, 8, 16, and 32, just like in the formula or the equation. And then I would just use Desmos to graph it and get those, the min, the max, and then the other min. Number 8 says write two possible equations for a quartic function, quartic meaning degree 4, with zeros at x equals -7, x equals 0, and x minus 3, or sorry, at x equals 3 with an order of 2. So you can see this last one has a 0 of x equals 3 with order 2, means degree 2 on that particular factor. So I took each of those factors, put them, and then I put an a in front. So right now to get two different equations, you can just substitute in for a to get two different equations. 9 gives this graph and asks you to come up with the family of functions that would go with that graph. So any function that would go through -5 and 2 on the x-axis. So the -5 corresponds with a factor of x plus 5, and the 2 corresponds with a factor of 2. X minus 2, sorry. And the reason I say it's degree 2 is because our curve comes down, it hits the axis, and goes back up. So it's degree 2. Number 10 asks us to use long division, so I'm going to go ahead and try that. 2x squared goes into, 2x goes into 4x cubed, 2x squared times. 2x squared times 2x is 4x cubed. 2x squared times 1 is 2x squared. Continuing similarly, I'm going to say minus 7 over 2x times 2x will give us that minus 7x squared that we need. Minus 7 over 2x times 1 gives us minus 7 over 2x. So continuing with the long division, we have, we're here, and then I have left over 9.5x, 4.75 times 2x gives 9.5. 4.75 times 1 gives 4.75. Subtract those. So my final answer then, when I divide 4x cubed minus 5x squared plus 6x plus 2 divided by 2x plus 1, is 2x squared minus 7 halves x plus 4.75, and the remainder is at the very bottom, negative 2.75. Question number 11 says, use the remainder theorem to determine the remainder of each division. In this case, we're going to divide this function by x minus 2, or we're going to find the remainder. So the remainder theorem says if I find this function at the 2 that you see here, goes here, and figure out what it is, that will give me the remainder. So according to the remainder theorem, when I divide this function by x minus 2, I get 38. Number 12 says use the factor theorem to determine whether the second polynomial is a factor of the first. We want to know if x plus 5 is a factor of this. So the factor theorem and the remainder theorem are tied. So what happens is if the remainder theorem gives a 0, then this will be a factor. According to that theorem, then, I need to evaluate this function at -5. And after doing all of that work and putting -5 in, I ended up with negative 12,170, therefore not a factor. I needed it to be a 0 in order for it to be a factor. Number 13 says determine the value of k so that when 3x to the 4 minus 4x cubed plus kx minus 3x plus 6 is divided by x minus 2, the remainder is 3. So what I really need to do is take that function and put a 2 in, because that's divided by x minus 2, and then when I do that, the remainder needs to equal 3. So I'm going to substitute the left side now. I'm going to put 2 into all of this on my left side and keep the 3 on the right. So we get something that looks like this with the 2 substituted in. And now I've only left the one variable k, so I'm going to go ahead and solve. So once I substitute it in and get k by itself, I end up with k equals negative 13 over 2. Question 14 asks us to factor, so I'm going to factor this one. To factor this one, I'm going to consider the factor theorem, and so I have to try numbers that will fit in, will be plus and minus 1, plus and minus 2, plus and minus 3, things that go into 6, or maybe plus and minus 6 as well. I'm going to go ahead and start trying. So I tried 1 and minus 1 and I did not get 0. I tried 2 and I got 0. Therefore, x minus 2 is a factor. To find other factors, I'm going to try synthetic division. Setting up my synthetic division, I get this. Remember to check that you're going in decreasing order, and if one of these is missing, so x3, x2, x1, if one of those are missing, you need to put in a 0. Okay, so to factor this, we checked 1, -1, and then 2. 2 we realized was a factor, so x minus 2 is a factor. I did use synthetic division and put 2 into the polynomial and got this quadratic. Now I'm going to see if I can factor this. Okay, so there are there's no more factors, so we can write this as x minus 2 is the first factor, and then the quadratic one, 2x squared plus 8x plus 3. Done. Question 15 says find the real roots. So we're going to start off like we did with the last one and find some factors that might go into this. Looking at the 20, we have to decide on plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 20. So anything that goes into 20. I'm going to do that now. That was very fortunate that 1 actually gives me 0, so then that means x minus 1 is a factor, and now I'll use synthetic division. After synthetic division, I can see that this is going to be x squared minus x minus 20. And of course that factors further to x minus 5x plus 4. So the roots then are x equals 1 from the first one, and x equals 5, and x equals -4 from the quadratic that we have. Are you having fun yet? This is great. Number 16 says solve the inequality. So I'm going to factor it and figure out where the function is bigger than 0. Once factored, I get that x minus 6, x minus 7, x minus 6, x minus 1 is greater than or equal to 0. Now I'm going to set up a chart using the critical points or x-intercepts of 6 and 1. So setting up my chart, I start at -infinity, and then I go left to right from smallest to largest. So then 1, and then 6, and then infinity. And now I'm going to figure out what's happening in between these values so that I know when this function is greater than or equal to 0. In here, I'm going to try what's between -infinity and 1. So 0 is in there, so I'm going to try a little 0. Let's try a little 0. So this would be negative, and this would be negative. So then the function would be positive here. Between 1 and 6, let's try 2. If I have 2 minus 6, that's negative. If I have 2 minus 1, that's positive. So the function is negative between 1 and 6. And then finally, between 6 and infinity, let's try 10. Sure. 10 minus 6 is 4, so that's positive. 10 minus 1 is 9, so that's positive. Those two positives make a positive. Those are the three intervals for this particular function, and so the ones that we're interested in are where the ones that are greater than or equal to 0. So we're going to look at this section, so -infinity to 1, and we're going to include the 1 because of the equal to sign in there. And then we're also looking at this other interval between 6 and infinity. So again, include the 6 by putting a square bracket, and then the positive infinity gets a round bracket. So these are the two areas where this function is greater than or equal to 0. Number 19, the question says, describes what happens to the function, this function, as we approach each value. So thinking first about the x goes to infinity, that means that this x here, very large, very, very large number. So the bottom will be a very large number. 4 over a very large number means that we're approaching 0. Similarly, if we use -infinity, we put -infinity here, this would be a very, very negative number. 4 over a very large negative number, it goes to 0 as well. Looking at going to 3 from the right side, I decided to set up a little table. So coming from the right side, that means greater than 3. I checked out 5 and got a y value of 2. Checked out 4 and got a y value of 4. Checked out 3.5 and got a y value of 8. If I were to continue, you'd see that it continued going up. So as x approaches the 3 from the right side, we're going to go towards infinity. Similarly, as x approaches 3 from the left side, so I'm trying 1, then I'm trying 2, and then I'm trying 2.5. If you want to really convince yourself, try 2.9. You're going to see that these numbers get more and more negative. So as x approaches 3 from the left side, from the negative side, y will approach negative infinity. Number 20, state the domain and range for this function. The domain is impacted by the bottom. This is going to give an asymptote at x equals 1. The range would be impacted if there's any horizontal asymptotes. Let's do the vertical asymptote first. So the vertical asymptote happens when the denominator equals 0, so then x equals 1. So for the horizontal asymptote, one of the strategies we used in class was to divide each term by x. So when you divide x by x, you get 1. When you divide this x by x, you get 1. So this would be 1 over 1. When you divide minus 2 by x, you're going to get something that's coming close to 0 as x gets very large. And same thing here. So then our horizontal asymptote will happen with 1 over 1. So effectively what I've done is divided every single term by x, and then you can see as x gets very large, these two terms, top and bottom, go to 0. So then I have this term, which would be, as x gets very large, this would be that large number divided by the same large number, so 1, and this would also be 1. So our answer would be 1 over 1, so it gives us a y equals 1 for our horizontal asymptote. So to finish up, the domain is everywhere except x equals 1. And the range is everywhere except y equals 1. Let's find the key features of this function, 6x plus 1 over 2x minus 4. The x-intercept happens when y equals 0. Solving when y equals 0, the 2x plus 4 that's on the bottom would multiply both sides and we'd just get 6x plus 1 equals 0. Then x equals negative 1/6. So to find the x-intercept, we need to set y equal to 0, and that's the same as making the numerator equal to 0, so x equals negative 1/6. This is the x-intercept. To find the y-intercept, we're going to set x equal to 0, which gives a value of 1 over negative 4. The vertical asymptote happens when the denominator equals 0, so when 2x minus 4 equals 0, or when x equals 2. And the horizontal asymptote, again, we're going to do what we did in the last question and divide each term by x. So getting that, we would have 6 over 2 as our horizontal asymptote, or 3. And that's y equals 3. Number 22, we've been given some specifics and asked to find the particular equation in this form here. So we're going to I think I'm going to use the vertical asymptote first. So that means that the bottom of my function could potentially look like x minus 1 because it has a vertical asymptote at x equals 1. So that would be the bottom. The top, remember our horizontal asymptote comes from dividing all of these things by x, and then so I would end up with a 3 on the top. So then I think that gives me the 3x. So that gives me that and that. The x-intercept is negative 2, and that happens when y equals 0. And y equals 0 when the numerator equals 0. So in order to make this numerator equal to 0 and get negative 2 for the x-intercept, 3x, what is that, plus 6? Let's just check that over here. 3x plus 6 equals 0, because that would be when the numerator equals 0 will give me the x-intercept. So then 3x equals negative 6, x equals negative 2. So then that does give me what I was looking for, so this must be my function. Number 23, we need to solve for x. So the first thing I'm going to do is cross multiply. So effectively all that I did was the 3 times the 2x plus 3 and the 1 times the x minus 2. I'm going to continue. I'm going to continue to isolate x by bringing the x's to the left side and the numbers to the right. So just isolating x, get x by itself, and you end up with x equals minus 11 over 5. Good luck. In number 2, we're solving the inequality, and it's number 24a. I'm going to get everything so that it's greater than 0 and work from there. In the next line, I need to find a common denominator so that I have a polynomial on top and bottom. Continuing to simplify my top. So my top is 4x plus 11, and my bottom would be 2x plus 4. So now I'm going to find out for this function where it's actually above 0. Okay, so looking at this function, the x-intercept happens when the numerator is equal to 0, so the x-intercept is negative 11 over 4. And the vertical asymptote happens when the denominator is 0, so that's at x equals negative 2. I'm going to set up a table now. My table is ready now, so I'm going to be able to analyze my function. So to recap what I've done here, I chose a number between negative infinity and negative 11 quarters and tried that number inside 4x plus 11 and inside 2x plus 4. I get negative and a negative, so our function is positive here. Similarly, between negative 11 quarters and negative 2, I tried negative 2.5 and I got a positive and a negative, so the function would be negative here. And lastly, the function will be positive between negative 2 and infinity. We've been asked to decide when it's greater than negative 2, and the greater than without an equal means that we're going to use round brackets for all parts. So this function is greater than negative 2, or in this case, this function is greater than 0 so between negative infinity and negative 11 quarters, round brackets, as well as between negative 2 and infinity. Thank you. Hope this video helps. See you in class.